through part A, right, so I've got the modulus of z minus 1 minus I is equal to mod of z minus 2. So let z equal x plus yi. So that's x plus yi minus 1 minus I equals x plus yi minus 2. Collect the real parts and the imaginary parts separately. So that's x minus 1 plus I times y minus 1 is equal to the modulus. The real part is x minus 2 and the imaginary part is y I. Okay, so to work at the modulus then, that's the square root of the real part squared plus the imaginary part squared. And the same on this side, square root of real part squared plus the imaginary part squared. So the square roots, they square both sides, then the square roots disappear. Okay, so expanding the brackets, so squaring x minus 1, so that's x squared minus 2x plus 1. Square the second bracket, that's y squared minus 2y plus 1. Square x minus 2, that's x squared minus 4x plus 4 plus y squared. So x squared on each side will cancel, y squared on each side will cancel. So the left hand side then is minus 2x minus 2y plus 2. The right hand side is minus 4x plus 4. So I'll take collect onto the right hand side to make a positive y, so that's 2y. Minus 4x add 2x is minus 2x. I got plus 4 minus 2 is plus 2. Divide by 2, so that's y minus x plus 1. Or taking y on its own, y will be x minus 1. So my locus, the equation of the locus there is y equals x minus 1. Now if we go back and just interpret this geometrically, okay, if I rewrite the first line, that's the distance of z from 1 plus I is equal to the distance of z from point 2. Okay, so what we're doing is we're finding the locus of points which are the same distance from this point as they are from that point. And to construct if I was constructing that, the locus of points which were the same distance from 2 points, I would construct the perpendicular bisector of the line joining those 2 points. Okay, but the question is just asking me for the Cartesian equation, which is there. And part B, I now want the locus, I want to show this locus is a circle. Okay, so again let z equal x plus yi. So it's the modulus of x plus yi minus 2 is twice the modulus of x plus yi plus I. Collect the real together, so that's x minus 2 plus yi is 2 lots of x is the only real part, and then the imaginary part factorized with y plus 1. So to get the modulus, that's the square root of the real part squared plus the imaginary part squared. That's twice square root of real part squared plus the imaginary part squared. Now I'm going to square both sides again here, but you've got to be careful when you square the right hand side, because you will square the 2 as well. So squaring the left hand side, the square root disappears. Squaring the right hand side, squaring 2 is 4, and squaring the square root just disappears, and does it. Okay, so let's expand this out. So squaring x minus 2, that's x squared minus 4x plus 4 plus y squared, and then that's 4 lots of x squared plus, and squaring y plus 1, that's y squared plus 2y plus 1. So expand the bracket on the right hand side. Like so. And then collect everything onto the right hand side. So 4x squared minus x squared is 3x squared. 4y squared minus y squared is 3y squared. Minus 4x becomes a plus 4x, or plus 8y. And if I take the plus 4 over, cancel out that 4, so there's the equation there. Now then, there's no xy products. The x and y are linear, and the coefficients of x squared and y squared are the same. So this represents the equation of a circle. Okay, I'm not asked to find the centre or the radius, so I don't need to complete the square to find that. Okay, so this represents, since coefficients of x squared and y squared are positive and the same, right? Positive and the same, and there are only linear expressions for x and y. The equation must be a circle. Equation is that, or a circle. If they wanted the centre and radius, obviously I'd have to divide by 3 first and then complete the square. Okay, but they didn't want that.